Testing. Okay. Uh, Introduction to wheeled vehicles, clutches, transmissions, and transfers. Okay. Wheeled vehicle clutches, transmission, transfers. We know that the internal combustion engine develops rotary motion at the flywheel on the back of the end of the crankshaft. We also know at any time rotary motion and power is available, it can be made to work. Let's see how this type of power is applied with the various types of machines that we think of the one-cylinder engine lawnmower. The power can be delivered to the power with one or two ways by connecting two units with a belt or mounting the mower blade directly to the crankshaft of the upright engine. Belt-driven mowers can contain a device tightening and loosening belt so the mower can be started and stopping while engine is still running. Some rotary mowers have upright engines using mechanical devices consisting of a disc to disconnect the engine from cutting blade. The devices are commonly called clutches. The purpose of the provide the means for connecting and disconnecting engine power from the machine is supposed to drive. The automobile engine was also disconnected from the vehicle wheels before the engine can be started. After it's running, the power of the engine must be ready for the use the driver wants. For instance, the driver must be able to make the vehicle go into engaging the power smoothly, gradually to prevent twisting of the braking the vehicle parts to keep from jerking the people overload. Some of the means must also provide so the engine can make the vehicle to go to the reverse as well as forward. There must be some way to vary with the speed between the engine and the driving wheel so that the vehicle will be able to run into the high speeds on level roads as well as heavy loads up steep hills. Besides furnishing power to make the vehicle to move, many engines also power such things as winches, hydraulic pumps, and used to provide a vehicle with taking the power of the engine, applying it to those of the devices as needed. The most army trucks can be moved by power to all wheels in front and the rear, and to this is too it requires additional units to place the engine power at each of the wheels. For the most part, the task described above is done in the units called clutches, transmission, power takeoff, and transfer cases. The job the mechanic maintain these units so that they will perform the job correctly. The subcourse is designed to provide you with the knowledge of the construction and operation maintenance of these units. Learning that 1. Explain the principle of the torque. The task of familiar with each of the process of winding our wands. To do this, we simply grab the winding of the knob between our thumb and the forefinger to roll with the knob. The action called the shaft to rotate inside of the watch, which in turn causes the watch to move in the spring of the wind. Now think of the anchor of the winding action, winding action, the winding action of the child's toy. Here again, the intent of the wind a spring that energized produced the spring type of the unwind can make a toy work. That's the key used to wind the toys consists of the shank of the fits for the outside of the winding shaft fairly long with the finger grip over the turn of the key. The device is designed for one purpose: to turn the shaft that will wind the spring. However, the toy spring requires more effort to wind than the watch spring, so finger grip is larger than the winding knob of the watch. Suppose we were to try and take the turn of the spring of the shaft without the key. By gripping extremely tight, we might be able to turn a little bit, but enough to wind it with the spring tight. With this reason for not being able to wind it tight, to begin with the inner end of the shaft is fastened one end of the coil spring. The nature of the shape of the spring forms loose coil of the spring is wound, but the position and shape of the coil is changed as it becomes tighter. However, the large amount of the work is needed to wind the coil because the steel spring tries to remain with the unwound condition. The work involved with the twist is applied with the winding on the shaft. The twist rotating effort applied with the shaft is called the torque. Torque is the twisting effort if it is applied with the making the effect with the rotate. We usually think of the work as required with the rotated shaft. However, when you grasp one end of the barrel tip for the edge of the roll, you would be applying torque to the end of the grasp. This effort you use to remove the screw cap of the jar. Torque is another example of torque. You put the wrench on a bolt and the stud. In this case, you will use the tool or apply with a twist. But let's stop thinking the way you now can stop thinking that why. We know good not applying a twist or fingers tighten the loosened bolt. The edit becomes quite simple when using the wrench for the reason to become simple because the wrench provides the lever action. We also know that the wrench handle is longer than can turn a nut or bolt much easier than the short handle. Let's think of the bolt and the nut spring with the shaft of the watch, with the toy of the wrench, with the shaft of the spring can be wound with quite easily. A person would feel a little foolish winding his watch with the wrench through, though a plate for the knob on the shaft of the knob, but actually the device over the same as if we were had many wrenches sticking out in all the directions of the shaft, and all other words of the knob, but the being larger than the shaft provides the lever to help overcome the torque required with the winding of the spring. With the keep in mind with the torque twist, we can increase the twisting effort by using lever. Now let's discuss the wheel vehicle with the mechanic employed with the torque. Let's start with the engine. The piston with the force down with the combustion stroke with the connection rod. Of the crankshaft throw down because of the crankshaft that's kept from moving down from this main bearing with the throw force with the shaft of the rotate. However, the shaft is hard to rotate because of the flywheel resists the movement of one or more of the other pistons being forced up with the compression stroke with the half or the power stroke of one piston is applied with enough of the twist of the crankshaft to force for the others. Upon a compression stroke, still have the power left over to do the work. You can see that the great deal of the torque is applied with the engine crankshaft. The purpose of the wheel vehicle is to transport with the cargo. The only way is passengers or cargo. The only way can be done with the vehicle with the wheels moved with the vehicle with the direction speed is desired by the operator. This means the wheel must be made to rotate. To do this, the torque is applied with the shaft, the drive with the wheel with the same. The torque is applied with the wrench for the tightening of the bolt. The amount of the torque of the twist is applied with the shaft at any other given point with the be measured. To explain, let's think of the stud that is being turned with the threads of the piece of the metal. For example, we'll say with the bolt, their stud fits threads tightly, therefore quite hard to turn even before it is tightened down. To explain the measure for the torque, we will use the wrench on the bolt with the wrench's handle with the 12 inches long with the marked 1, 6, and 12 inch position. Further, there are other discussions will be disregarded with the weight of the wrench. With the wrench placed on the bolt, we will know that the sum of the effort we'll need for the turning of the wrench. We'll take 1 pound weight to apply the effort of the plate for the weight of the 1 inch marking. It probably won't be enough to turn the bolt. However, there must be agreed that the sum of the twist is applied with the bolt. In fact, we know exactly how much torque is being applied with the gift of the bolt because they have 1 pound weight pulling down the wrench of the 1 inch from the center of the bolt. The term used to express the torque of the power in inches and pound-foot. Sometimes you see that the words reverse. Actually, reverse words in inch pounds and foot pounds are used to express the power of the work instead of the torque of the use of the terms pound, inches, pound, feet. And with the lesson in our experiment, we will place 1 pound inch twist torque on the bolt. As we wait on the move of the wrench for the handle, the amount of the twisting being applied with the bolt will increase. Remember the lever action we'll spoke about when the move of the weight further onto the handle will increase the leverage of the 1 pound weight applied with a 6 inch mark, and it will be applying 6 of the pound increase over the torque. The weight is placed on the 12 inch mark would be applying 12 pounds inches on the torque. You can also say that you have 1 pound a foot of the torque being applied with the cover of the 12 inches equal to 1 foot. If the wrench is 24 inches long, the weight placed on the 24 inch mark would be applying 24 pound inches or 2 pound feet of torque on the bolt. If we remove the weight of the graph of the weight over the hand with our hand with the 12 inch mark, we can probably turn the bolt. However, for each of the pound of the pressure applied with our hand, we are applying 1 pound a foot of torque on the bolt. Because our hand is 1 foot from the center of the bolt, we will be pulling the wrench to apply with the torque of the bolt only with 15 pound feet with a twist in the knee of the turn of the bolt with the greatest amount of the torque that can be applied with the wrench until the bolt becomes hard to turn. Now to understand the effect of the torque of the twist on the shaft that shall be discovered in the items used instead of the wrench in the turn or to turn the shaft. The items are called gears. Lesson learning event number 2. Describe the purpose of the type of the operation with the gear and the gear trains. Automotive vehicles must have many of the components that can take up the power from the engine and deliver with the wheel of the vehicle that not only must power but simply deliver to the wheels, but the components must be arranged to several things. The military wheel vehicle is designed to do the following: have the grading pulley power must have high and low speed with the transverse, shovel inverse as well, the forward operated on rough ground as well as smooth with the road and deliver power to the front of the wheels as well as the rear wheel. A simple shaft of the belt chain with the engine's wheel will not allow these things to be done. Therefore, components often referred to with the gearbox make up the referred to with the power of the train with the vehicle with the units of the contain with the various type of the gears to do the job. The gears are made in the shape of the size. Therefore, purpose to transmit the power of the one shaft to another. The shaft might be parallel to each other or at an angle with each other. Type of the gears. You can now see what the gears must be shaped with the job that is due to. They are to do all gear with a certain common of the usually feature of the usually of the round wheel with the teeth of the notches formed some way with the outer edge. They will have a hole in the center so that they can be mounted on the shaft. This is an external gear, figure 1, and then you have your spur gear, figure 2. And the spur gear can be identified with the straight teeth. The teeth is spaced evenly run with the trade across the outer face of the gear. This type is called the external tooth gear with the cover of the teeth that are on the outside of this most common type of the gear. You'll see that it can be used to transmit power from one shaft to another as long as the two shafts are parallel with the two of these gears are mesh. When can turn the other, the one is doing with the driving is called the pinion and the driving or the driving gear. The one being turned is called the driven gear. Note that when these gears are in mesh, only one tooth of each of the gear when the contact with the stream for the entire load of the being delivered through the one tooth of each of the gear. The one tooth comes out of the mesh, another moves in, takes its place. Therefore, there are two things problematic about this gear. By having only one tooth engaged at the time, the large loads might break off of the tooth. Also, one of the tooth going into the out of the mesh time causes the gears to be noisy. Figure 3, helical gears. any other type of the game with a helical any other type of the gear with a helical tooth gear with the teeth of the gear acute with the angle with the mesh making the teeth along with the two gears from the mesh with the portion of the two and more teeth in contact at all time. Shift the force below the type of the gear and spread over the large area with the helical tooth gears can handle large loads with the spur gear and also because of the way of the teeth that engage with the disengage the gears are fairly quiet. However, the big disadvantage with this type of the gear is that whenever the helical gear is driven in another gear with an underload, the gears are trying to slide sideways when the shift, their shift become the shape of the teeth. Their shafts become the shape of the teeth. Driving the gear will try to slide the other way. The action is called the side thrust. The helical gears are used in the shaft that must be designed to prevent the gears from moving sideways. Figure 4, the herringbone gears. If there are times if the gears are made with a hardly extreme of the heavy load due to the helical principle of the long tooth with the contact with is able to double the helical gear called the herringbone gear, but it was designed, you will notice that there's no side thrust on the type of the gear because of the shape. This gear is also fairly quiet. Figure 5, bevel gears. Whenever the wind power is delivered the angle with the teeth of the gear, but the must be differently with the type of the gear, with the called the bevel gear, with the nose of the two of them mesh with the change of the direction of the power by 90 degrees of the gear are available in several designs. The spur bevel is a straight teeth, the same with the regular spur with the gear, with except for the teeth of the arrow cut with a 45-degree angle with the side of the gear with the screw bevel was cut and similar in the helical gear, except for the teeth that are also cut at 45-degree angle with the side of the gear. This is advantage with the screw with the bevel of the gear over the spur bevel gear is same as those the helical gear over the spur gear. There are other designs of the type of the gears, such as the spiral bevel, the hypoid, which are used in the rear of the front axle wheels. Figure 6 is the worm gear. Worm gear is another type of the gear with delivering the power with the angle with the principle of the gear arrangement. Similar to the bolt now that the worm shaft has a coarse thread cut on it as it rotates one with the teeth of the worm gear into the worm gear is very compact, white, and is often used with a heavy load that must be transmitted at an angle. Figure 7, the internal gear. Any other type of the gear with the internal gear with the ring with the gear tooth cut into the inside of the teeth, usually with the spur type, the tray of the curve, the type of the gear is normally used for the special purpose only. Gear principle: speed, the direction, rotation of the shaft of the gear with the operative, depending on how the gears are arranged. The two external tooth gears over the mesh, they will turn into the opposite directions. But the principle can be used to provide forward or reverse gear for the vehicle. With the third gear with the head of the gear train is called the idler. The driving gears will turn in the same direction. Idler gear will rotate with the opposite from the driving of the and the driven gears will not change the speed with the torque with the driven gear. With a large driving gear mesh with a small driven gear will increase speed, reverse the direction of the rotation, and reduce the amount of the torque delivered. The small driving gear mesh with a large driven gear will decrease the speed and change the direction of the rotation, increase the amount of the torque delivered. An internal gear mesh with the driving and external gear with the increase of the speed with the decrease of the torque with the external gear mesh with the driving the internal gear with the decrease of the speed with the increase of the torque, but the gears will always driven in the same direction. Worm shaft driving with a worm gear will deliver their power at 90 degree angle. The worm shaft is always for the driving or worm shaft is always for the driving or input member for each for the rotation of single thread of the worm shaft of the worm gear with the rotate with the distance of the 1-2 with the speed torque ratio of the worm gear 3-4 determined by the comparing the number of the threads of the worm shaft, the number of the teeth of the worm gear with the worm shaft of the design with the single and double threads. Learning event number 3: explain with the principle with the gear and torque ratio. The term of the gear ratio with the you would express with the comparison with the speed of the rotation with the two gears is always stated with the first number that represents with the rotation with the driven gear, with the second number that represents with the driving gear, and also with the first number that represents with the number of the times of the driving gear must rotate to make the driven gear rotate one turn. Some example of here how the gears are stated as are in a 1-to-1 ratio indicate that both gears rotating the same speed, with the ratio indicate with the small driving gear with the mesh for the driven gear is twice as big, with the driving gear must turn twice to determine the driven gear once. A 0.6 to 1 ratio indicates the driving gear is the biggest. Every 3 turns that makes for the driven gear will rotate 5 times. Therefore, the driven gear is only has makes for the 6/10 of the rotation with the rotate of the driving gear. 1 for the gear ratio between the gear that is determined by the counting of the teeth and driving and the driving and the driven gear. You must remember that that when 2 gears are in mesh, the driving gear rotate with the distance for the 1-2 of the driving gear will rotate the same amount. Torque ratio. Understand the torque ratio of the gear with the necessary to understand the principle of leverage applied with the gear with the recall with the discover applying with the torque with the bolt earlier in the lesson to discover the torque ratio between the gear with the we must think of the force of the shaft of the gear from the gear to another gear from the second gear of the shaft that is amount of the do will refer to the items in the input shaft of the gear with the output gear with the shaft of the input with the driving member whenever the output with the driving member if the driving member the first look of the input member the shaft with the gear and the gear bringing with the turning force into the gear with the train for the only purpose that we say with the engine and the motor is driving the input shaft that is applying 25 pound-foot 25 pound-feet of torque on the shaft. To begin, we think of each for the tooth of the gear being the same as the lever of the wrench, as we discussed earlier. Remember that when the two gears are meshed with only one part for the two teeth that are touching, each on the other, there any one time that there was, must remember the entire load between the gear for these teeth. For our discussion, we will think of the driving gear as having just one tooth with this is going to do so with the work with a further help understand a little better. We'll say that the gear is 2 feet in diameter, so one tooth will be exactly 12 inches long. We said that there was a torque of 25 pound-feet applied with the shaft. This means that the torque of the direction rotation it could lift the 25 pound with one out of the 12-inch mark with the end of the tooth. Just the reversal was explained with the wrench for the shaft, the turning with the gear with the width, the wrench for the we wanted to turn the shaft that we bolted inside with our example. But remembering the loss of leverage, we know that the smaller gear will deliver the more torque than a larger gear than 6-inch mark with the side of the 12-inch of the gear instead of the 24-inch gear with the tooth of the color of the lift of the 50 pounds to cover the greater leverage. You can see you improve with yourself with the holding the stick straight with the out of the arm's length with someone hanging with a small weight with the very end of the stick. You will notice how and hard with the hold the weight with the no have the person take the weight off the end of the stick and hang it twice with the much weight on the center. You will see that it requires the same effort to hold the twice with the weight with the center until the end hold with a single weight on the end. From this, we can see with the smaller driven gear with the comparison of the driven gear with the deliver, the more torque with the drive, and the heavier load within the big gear with the after you have the gains experience. You will know that the driven gear with the almost gear stream, but the smaller with the driven gear, the exemption to this is if you want to increase the speed with the torque, then you input with the driving gear would be bigger than the driven gear. You will be the mesh with the 1 tooth with the driven gear with the 1 tooth with the driven gear with the 1 tooth with the driving gear. One driven gear with 1 tooth of the driven gear with the both of the gears are the same side, but we think of the driven member of the gear with the train would be exactly the same as the width of the wrench on it. The long wrench is then easier to trim the bolt. We said that the input gear is applied with the force with the 25 pound with the on the end. Then it is amount with the force applied with the torque with the apply the tooth with the driven gear with the tooth of the gear with 1 feet long with the a torque of 25 pound-feet will be applied with again for the shaft of which the driven gear is mounted with again remember the one with the discussion of the wrench we know that the more effort described with the turn of the bolt with the short wrench with the long wrench there if we apply with the input for with the 25 pound with the again for the output of the 24-inch of the we could get twice the much important torque with on the shaft on the 12-foot on a tooth of the 12-inch long. How again we compare with the output gear with the knob you want to watch is the knob that made bigger is easier to wind. The watch, the same principle applied with the driven gear is in the gear train. Driven gear, the bigger of the driven gear, you can increase the torque. How does we apply with the as to wheel of the vehicle? The mechanics. Do you look at the view of the thing of the wheel vehicle? It depends on the gear that's beginning with the vehicle engine. Can only produce so much power, but the running it is too fast to produce the more power than when it is idling. The power to develop the engine sent to the vehicle in the form of a twisting motion torque with the flywheel at the end of the crankshaft of the vehicle to start with the standstill of the gear. Deal with the torque is required to get into the motion. In addition, with the engine is not running high with speed at this time. Therefore, the torque of the engine is applied with a small driven gear within the term of the drive of the large driven gear with the increase of the torque and the help of the engine get the vehicle started. After the vehicle is motion, less torque is required to keep it in motion when occur with the driven with the gear with the can be near with the same with the side. With the other words, we can give the gear train with 12 speed more of the torque. Speed more than torque. The vehicle comes to the high hill with the ratio will have the chain with again. Now with the driven gear will have to be small with the driving gear. Driving gear will they have to be small with the driven gear to increase the torque within. So doing so will give the up speed with the increase of the torque. Some of the torque ratio will compare with the gear ratio with the driven gear with the 12 teeth with the driven with the large driven gear with the 24 teeth with gear with the ratio of the 2 to 1. In other words, the driving gear has the rotate 2 times with the make with the driven gear rotate 1, but in the gear train we double the torque and cover the speed of the half of the driven gear with the same side of the driven with the gear ratio 1 to 1 input output torque speed with the same of the input gear with the 24 teeth with the output with the gear with the 12 teeth with the gear ratio of 0.5 to 1 in this gear train and reduce the torque of the increased speed. Operating at a gear train show the number 2 speed with the number 2 in 1 gear. Let's imagine the crankshaft attached with the gear 1 illustrated above with the crank is the turn with the shaft will cover the gear 1 turn the same direction with the crank with the amount of the torque is applied with the shaft depending on how hard with the crank with the resistance with the pain with the bucket of the gears 1 2 with the external gear with the mesh with the therefore rotate with the opposite direction because the gear 1 is larger than the gear 2 with the gear 2 with the be returning with the faster with the gear 1 result of the loss of the torque. Remember the gear 1 the gear train must add decrease the torque and the increase speed. So let's just go back there. You see 2 to 1. Describe the construction and operation of Planetary Gear site. The often necessary design of the gear train with the provide with the main many with the gear ratio. The often necessary with the train must these trains must not be too large or quickly aimed for the requirement of planetary gearing. All right, this shows the planetary gearing system set. Planet pinion, the sun gear, the internal gear, and your planet pinion carrier. Maneuver the arrangement of the components and shaft of the cup with the resemblance of the planetary pinion with the flame of the universal circling around the stern of the shaft, given them the same, given the name of the planetary gear set. With the center over the stern of the gear, it can be either spur gear with a helical gear with the containment of the through of the shaft. So that it can act as either input-output mode. Normally, these three planetary are in mesh for the stern of the gear at all times. Some of the sets will have two or others four. They are mounted on and are free of the rotate individual shaft of the planet carrier with the framework designed to hold with the pinion with the respective position plan with the carrier with the can be rotated with the pan walked around with the sun gear with the carrier with it can also contain shaft that may act with the input-output member, the output of the outer internal gear with the contact mesh with the planet pinion with the call with the ring gear, and it can be also input and output member. Principle of the planetary gear set operates for the base for the driven driving one unit and holding the one unit and taking the output from the free unit with the be placed with the brake of the band with the ground the ring gear with it can prevent it from turning in the sun gear with the driven and under the condition will cover the plane with the position with the rotate with the ring gear hold. From the turning of the planet pinions, we'll have the to make walk around with the inside of the ring gear, with the outside of the sun gear, and doing so with the planet pinions will carry with the planet carrier with around them with the planet carrier with its help with it, so they cannot rotate with the sun gear with the driven with the planet pinion with the force of the ring to the turn. If the planet carrier's help with the ring gear with the driven and the planet pinion will force with the stern of the gear to turn with the stern gear's help with the planet carrier with the driven the planet pinion with the will be forward with the rotate they will drive with the ring gear. Actually, planetary gears and such things, automatic transmission, disc clutches, brake band with the control of the holding driving member. Usually bands and clutches are controlled automatically. Operating principles fully understand with the move with each of the member planetary system. Let's consider with a few basic operating principles of the planetary gear set with the planetary carrier with the sun gear with the held together with the pinion that cannot turn with the because they are locked by the sun gear. This will cover the unit with the term one unit with the none of these parts will determine themselves. Will give the U with the direct with the drive. You will have the one over the P shaft. If the sun gear is held with the planetary carrier with its turn, then the ring gear will turn with the pinions will walk around with the sun gear. Because the sun gear will not move with the pinions to talk with the turn as they walk around the sun gear with the mesh with the ring gear. Therefore, the ring gear is pushed by the turning pinion of the ring gear will determine the same direction as the carrier. If the ring gear is held with the sun gear with the turn with the carrier with will turn with the pinion with the mesh with the sun gear with when the sun gear is turned with the pinions will turn with the pinions are also meshed with the ring gear held the pinions therefore walk around with the ring gear, this cover the carrier with the turn with the pinion with the carrier with the held with the sun gear with the turn with the ring gear with the turn in the reverse. We cover the opposite pinion with the IR mesh with the sun gear with the turn with the pinion with the also turn. However, the pinion with the turn with the opposite direction. Sun gear with the pinion also mesh with the ring gear driving with the ring gear with the cover the gear with the held with the cannot turn with the external gear with the driving end with the internal gear with the direction with the turning in the same. The planet pinion is turning the opposite from the input. Rotate with the ring gear and the reverse. There are 5 basic rules to the planetary gear operation. If the planet carrier is used with the output of the operation with a reduction of slower speed, then more torque. If the planet carrier is in the input set of the operator, same in the overspeed with the more speed and less torque. If the planet carrier is held, the set operates in reverse. In any two parts of the locked together, the set operates with direct drive. If no parts are locked together, if none of the are held, it's the same. Operates normal. However, there are a few more things that you should remember. An input member receives the power from the source of such as the engine. Output member to transmit the power for the drives and wheel of the vehicle. And the stationary member is one that is held by a band or a clutch. The stuff that it cannot turn. Lock members are held together. Speed range of the planetary set. Even the first 3 of the above the rules, we can get the 6-speed range. But remember that when we reduce the speed, we increase the torque. When we increase the speed with we reduce the torque. If the sun gear is held with the planetary carrier with the turn with the ring gear will have the turn faster for the carrier overdrive. With the sun gear is held and the ring gear is turned with the planet carrier will determine the slower within the ring gear reduction. Ring gear with the held with the sun gear turn with the planet carrier with the turn slower within the sun gear with the reduction. The planet carrier is held with the ring gear is turned with the sun gear with the turn reverse and faster than the ring gear with the overdrive with the reverse. The ring gear is held with the planetary carrier to turn with the sun gear with the turn faster than the carrier to overdrive. If the planet carrier is held with the sun gear with the turn with the ring gear with the turn the reverse slower than the sun with the gear reduction. In reduction in reverse. Lesson 2: Fundamental clutches.